Hey there, math fans. A student in my pre-calculus class saw me flip an inequality. And they're like, what just happened there? What's going on? So I thought I'd make a little comment about this, and then we'll do some bonus tips. So the types of inequalities we're solving in our pre-calculus class are pretty much like these on the left. At the end of this, I'll say a couple things about these, and if that interests you, I could say more. Let me know in the comments. But most people have this thing kind of memorized of if I add or subtract or multiply and divide, we can work with it just like a normal equal sign, except there's this weird thing when we have a negative. And that's the one we have to be careful about. So really what's happening, my cat is helping here, is a negative flips the side of the number line you're on. So I think a lot of times the confusions have to do with a misconception of what that negative symbol means. It doesn't necessarily mean you're dealing with a negative number even. So what's happening there, what Penelope, my cat, is doing, is switching back and forth between 6 and negative 6. That's all that's happening. What's actually happening is we're plopping a negative in front of it. So if I say negative 6, we get back over here. It's just back and forth. Keep putting another negative in front of it. You go back to the other side. So a negative means flip. Flip to the other side of the inequality. Now, whatever the rules are, I don't ever think in terms of rules. I think in terms of you can experiment. So we'll show some visuals here in a second. Hold on. We'll come back to you in a moment, Penelope. Let me move that for a minute. You're too distracting. Okay, so here we go. So first thing, you can add or subtract from both sides. So this, and I'll show you a visual of this in a moment, this is x is greater than 5. Here you can multiply both sides by 2. That also doesn't flip anything. Nothing gets flipped. You just say x is less than or equal to negative 6. So here's the interesting case. Okay, and I think of it in two different ways, but I had intended for this video is first we deal with the negative. Now the moment you multiply both sides by -1, you've flipped everything to the other side. You've done a bit of a mirror image, and I'll show you how that works. And I'm not claiming to have the best explanation, but I wanted to use my cat there. So for example, if you say I'm considering all the numbers bigger than 6, and then you multiply all those numbers by -1, you're going to be talking about the numbers on this side. So that's why you switch from being everything greater than or equal to 6. If you take everything greater than or equal to 6 and you flop it to the other side, you put the cat at each spot, that looks like a person. You move him to the equivalent spot on the other side. You can see that instead of being greater than or equal to 6, you're going to be less than or equal to -6. So if you can just think of the negative as flipping where you want on the number line, it explains quite a bit of things that often confuse people. So that's what's happening here. The other thing is you can just go back and try numbers. Like if you didn't believe this or wanted to argue with someone about this, you can try. You could say, well, does 0 work? No, because 0 is not greater than or equal to 6. Does -4 work? No, it's not big enough. Does -6 work? Yes. No, it doesn't. That gives me 3. What am I talking about? Does -12 work? So that's what's happening when you do this. The rule of thumb, just to remember, is if you multiply or divide by a negative, it flips. The other comment is there's a way to avoid that. When I was a student, I sometimes tried to avoid this by just adding this to both sides. That got rid of the negative problem, and then I subtracted the 6, and then I multiplied times 2. But you might notice that is the exact same thing. By adding it to the other side, you're also doing the flipping. Okay, so let me just show a couple visuals I have prepared. There goes Penelope again. I may or may not do those bonus ones. You'll have to let me know if you want to see them. But let's get ready, Penelope. And I have a few examples. So first here I have Harry the Husky pop doll. And I have x is greater than 8. Now I'd like to think about, what if I add something? Right now I'm adding 0, so it's just x is greater than 8. But what I'm going to do is I'm going to move it over. So now I'm doing 1. So x plus 1 is greater than 8. Well, that requires x is greater than 7. So you can see how adding 1 in that first inequality, you can subtract from both sides. Nothing flips. It's really just sliding. You're staying on the same side, so to speak, here. That's the game. And you can also go the other way. You can subtract. Okay, so that's 1. Thank you, Harry. We'll get rid of you. And here, let's throw in Julio. So this time I'm going to say I'm less than or equal to a negative. So I'm going to switch to the other side of the number line. And I'm going to say x divided by 0.2 is less than or equal to negative 3. You can multiply both sides by 0.2. It doesn't involve any flipping. You can then move over, like if I did x over 1 is less than negative 3. This is all rounded. X over 2, you can just multiply. Nothing gets flipped. So the interesting case, again, is our Penelope jumping case. Stop. So if I'm trying to solve this, so let's say I have x is less than or equal to 6. Let's draw that. Hopefully I shaded the right thing. Yeah, there we go. And then let's say someone comes along and they want us to deal with this. X over negative 2 is less than or equal to 6. So what we do is kind of a two-step game. So visually what happens is we flip to the other side. So we say, come on over. And we flip there. And that gets rid of the negative, but it also flips our inequality. Now we're on the other side of the number line, and then we multiply times 2, which is going to make it negative 12. That's it. And then we have our new inequality. I don't know if I have that ready to go. Let's see. But it's greater than or equal to. And again, you can always test it. You go back to whatever you had first and you say, if I take a number bigger than negative 12, like 0, does it work in the first line of those? So if you're ever unsure, you can do that. But it's a fairly simple thing to remember. Multiply or divide by negative, you flip to the other side, which causes you to flip the inequality. Okay, that was overkill. The other comment I make to students is if you ever get mixed up and don't know what to do, you could just solve when this is equal to this and this is equal to this and then make appropriate conclusions. But in this case, you can handle just subtracting 6 from all. So you're actually solving 2 inequalities at the same time. When you do this one, you're just subtracting 6, which is legal. You're dividing by 2, which is legal. Nothing flips. Done. So that's a simple version of the first inequality. The other ones are just special things that happen to come up quite a bit in calculus and beyond. So the second one comes up quite a bit. And typically what I tell students to do is to simplify, but there comes this moment. And we don't solve, in my experience, I don't solve enough inequalities with more complicated functions to learn a bigger method here. So I tell students, I know how to think through this. I can do some experimentation. But I say, if you don't know what to do, come over here, find when it's equal, because that will help you then answer the question. You go, well, there's 2 answers, minus 2 and plus 2. And then in your head, think about a number line. So this is my tip if you ever get stuck on one of these. Don't try to manipulate it, just solve when it's equal, and then think about these 3 regions. The people that live over here, the ones that are between negative 2 and 2, and the ones that are over here. And then try numbers in each one and just see what works. This is sort of true for all of this, is you could find when it's equal, and then just try numbers on each side. So you could try like, does negative 10, anything on that side work? No, it doesn't, because that's going to give you 100. So sorry, you don't get to be here. Does 10 work? No. Oh, it's negative 2 to 2. So that's another way to solve. sort of a fail-safe if nothing else works. Now, the truth is what happens here is it also essentially flips for the negative for the same reasons. But as I said, I find that that's usually more confusing to explain. Absolute values are a special one because absolute value means your distance from zero. So this is just the same as saying you're between here and here. Most students sort of get that, but they maybe don't know this one. So this one is saying, same thinking, that this is between 3 and -3. But if you think about that, that means how far away from 5 can you be? If you're allowed to be within 3 of 5, where are you? Well, x is less than 8 and greater than 2. So those are, to me, the hardest inequalities that I see students get stumped on in calculus. Everything else we just did was kind of the more typical thing you're doing. The point is, this is not something to fear. If you only had to remember, solve like normal and multiply it or divide by a negative, flips. And even if you forget that, just solve when it's equal, draw a number line, and make appropriate conclusions. All right, I hope that helps you with your inequality solving.